So ranged combat is something that needs to be implemented into many games, but this is a feature that needs to be implemented well if being added within any game. Ranged combat can make your game so much better and way more entertaining for the player. As you can see on screen, this is what we'll be creating today, and let's just get started. But also just real quick, if you could subscribe and drop a like on this video so you're able to help YouTube push this video to more aspiring game developers, then it would mean the absolute world to me. Thank you so much, and now let's get started. So first, let's create a new scene for the arrow, and then we're going to give our player the ability to fire this arrow. Then we're going to go over the actual visuals of the bow. But for now, let's create the visuals of the arrow and the actual firing system. To do this, we're going to go up to the top and we're going to create an area 2D. This is going to be a new scene for our arrow. So we can say area 2D, and we can rename this to arrow because this will be our arrow scene. We can say Control S. We can save this into our scenes folder, and we can save it as our arrow TSCN. And now in our arrow scene, we're going to need 3 different nodes. First, we're going to need the sprite. This is going to be for our arrow. So we can say load, and we can go with the Godot icon. We can just make a little placeholder arrow here, something decently small, just like this. And we can always come back and we can change this arrow to match and look better. And we can go to our visibility. We can go to modulate, and we can change it to complete darkness. And we don't want the arrow to shoot out, facing this way. So we can go to our rotation, and we can just rotate the sprite 90 degrees, just like that. Now, within our arrow, we're going to need a collision shape because this is an area 2D. So we have to have a collision shape so we can understand when the arrow hits an object or hits a player or an enemy or whatever the arrow may hit, right? So we can go with something like this. We can go to transform. We can rotate our capsule, and we can expand it a little bit, and that's going to be our collision shape. So if this blue hits whatever object that is aiming towards, if it's aiming towards the enemy and it enters this blue, then it's going to do damage to that enemy, right? And then on our arrow, we're going to need one more thing so we don't cause a bunch of lag, and that's going to be a visual on-screen enabler. Visible on-screen enabler 2D, just like this, because this is going to make the arrow disappear once it leaves the screen. So we'll just say something like, once this area here leaves the screen, then we're going to hide the arrow. So, or let's make it actually a lot smaller. Let's do something like this. So once this zone here leaves the screen, then we're going to click hide, and the arrow will be hidden. So that is basically our arrow. Now we want to go to our arrow. Let's create a new script. Let's create an arrow.gz script. Let's save this into our scripts folder, and let's create. Now, for now, we can actually keep the process function, and we're going to keep the ready function, because in the ready function, I'm going to call a set as top levels. So this is going to allow us to have the arrow on the top, so it's always visible and it's never hidden behind something. So we'll say level is true, just like that. And then at the top, let's create a new variable, and this is going to be for the speed of whatever arrow we're shooting. So we'll say var speed, and this speed for now will be equal to 300. Remember, we can always come back and we can change this. Now in our process function, this is going to be the actual speed of the arrow and how it has movement. And how this movement works is whenever it's spawned in, it's going to automatically play this. So the moment the arrow is spawned in, it's going to loop this, and it's going to change the position infinitely until the arrow is hidden once it leaves the screen or once it hits an object, right? So we'll say visible plus equals, and then this is going to be a vector2 dot right, and then we're going to have a multiplier on here with speed, and we're going to have it rotated at whatever the rotation is, which will pass through eventually. I don't know why I spelled all of that completely wrong, but rotation, and we'll pass this rotation through whenever we have our player, whenever we actually fire the arrow, and then we'll say delta, just like that. We can save it, and then if everything works once we spawn, but the arrow will never disappear once it leaves the screen, right? So basically what this does is it changes the position, and we're going to move towards the right, we're going to move positive, and we're going to change the speed infinitely. So it's going to go the same speed as the 300 up here, so we can go back and change it, and it's going to rotate whatever we pass in the rotation variable to be, which we'll go over in a minute. But this visible on screen enabler, we can go up to node, we can send a signal screen exited, and we can send this to the arrow. And when the screen is exited, well, we want just to queue free the arrow so it just disappears, so we don't cause a bunch of lag. But now our arrow scene is complete. But now let's go to our player, and let's give our player the ability to actually shoot this arrow into the world. And to do this, well, first let's go to the player and let's add a marker 2D so we know where we want to spawn the arrow. And then let's go to the player script, and in the script, well, this is going to be a lot. So first I'm going to minimize our play animation function just so we can have just the physics process function up here. And at the very top, we're going to create some new variables. And these variables are going to be one for our bow and see if it's equipped or not. So we'll say var bow equipped. So we can check if the bow is equipped. And for now, it's going to be equal to true just for testing. So we can, have it automatically equipped. Then we can say var bow cooldown. And this bow cooldown is going to be how long we have in between arrows, because we don't want to be able to fire infinite arrows at once, right? So for now, whenever it's equal to true, that means we're able to shoot. And then we want our var arrow scene, and that is going to be a preload of our arrow scene. And to get that, well, we have to find the path, and that shouldn't be too hard. Should be in the scenes folder. And that is it right there. So that's the arrow scene. Boom. Okay, so now all of our variables are complete, and I want to go into our physics process and make the actual shooting. So whenever we click the button, it's going to shoot. It's going to spawn it at the marker 2D, and it's going to release it into the world, right? So to do that, let's go down here under the move and slide, and let's create a local variable. And this local variable is going to be our mouse position equals get the global mouse position. And then we want our marker 2D, and this is how we're going to rotate our arrow. Our arrow. We're going to rotate our arrow by pointing our marker 2D at the mouse position, right? So we're going to point our marker 2D towards the mouse position, and then we're going to set the rotation of the marker 2D to equal the rotation of our arrow's instance, or our arrow's instanate. So we're going to set that so it's going to rotate the arrow the way that our marker 2D is rotated, which is what we want. Then we go down here and we can make an if statement. If input dot is action just pressed, and we're gonna have left mouse, which we don't have, so we'll create that here in just a second. And then so if we hit the left mouse button, which is our shoot button, and the bow is equipped and the bow cooldown is equal to true, then now we want to fire, right? So our bow cooldown is now equal to false, because we do not want to be able to fire once we're already in the fire. We want to create a new variable so we can actually instance the bow scene, or the arrow scene. So we'll say var arrow instance, because we'll keep it pretty simple. And we'll say arrow dot instanate, and arrow is, remember, the variable that we created up at the top of the scene, and where we preloaded the scene into the player script. And then we'll say our arrow instance, and this is where we're going to set the rotation. So we're going to set the rotation. Remember, we created this variable within the arrow scene, or within the arrow script. So we're going to set our rotation, and we're going to set that variable to equal the rotation of our marker 2D, right? And then we're going to have to set the position of this arrow that we're instancing into the scene, and the position is also going to be equal to, guess what, the marker 2D, right? So we'll say global position. I don't know why it's not giving me any autocorrect terms here, but we'll say marker 2D dot global position, just like that. And then we'll add the child to our player, because this is when we spawn the arrow, and we'll add the child of the variable that we just created with the instance. So we have everything loaded into the scene. So now our arrow has a rotation angle, so it knows which way it's going to be shooting. And we have the global position, so it knows where the arrow is going to be spawning. And then this is where it's going to actually shoot the arrow. Now the arrow's been shot. But how do we be able to shoot the arrow again? Well, we have to, we can play real quick. If we go to our world, we click F6. And you can see if we click the left mouse button, it's not going to work because we did not go to our project settings, input map, and we did not create a new mouse button, which is left mouse. Add left mouse is going to be a mouse button, and it's going to be the left mouse button. But now if we click F6, we go to our world. We can run around. If we click F6, you see that it is huge, but it fires one arrow and we cannot fire anymore. So that's an issue. And to fix that, we can go down here and we can say await timer, because this is going to be our cooldown. So however long you want your cooldown to be, you'll say await get tree dot create timer, and then this is where you put the time. So I don't know, I'll go 0.4. So we'll wait 0.4 seconds before we enable our bow cooldown again. Boom. So we'll wait 0.4. Once that's over, bow cooldown equals true, and we can, you know, replay this function. So if we click the world, we click play, we can run around now. We click this button and we can send out arrows, whatever way our mouse is pointing, and this works. But these arrows are very, very, very big. So if we go to our 2D scene, we can just go to our arrow real quick. We can go down here to our transform, and we can change the scale to like 0.3, maybe even smaller than that. I don't know. We'll go 0.2, something like this. And if we go back to our world, we can play real quick, and that looks a little bit better, and we'll just go with that for this tutorial. But yeah, so now we can actually shoot the arrow, but now we have to, you know, have a quick way to toggle the bow on and off, so we can't just always have the bow toggled on. So to do this, we can go into our physics process function. We'll just go right above the mouse so we can keep everything organized, and we'll say if input dot is action just pressed, and this is going to be E, which it looks like we've already created, and we'll say if bow equals equipped, then we want bow equipped to equal false, right? And if that's not true, then we want bow equipped to equal true. So now this is a little toggle function. So if bow equipped is true, then we want bow equipped to equal false. If bow equipped is not true, then we want bow equipped to equal true. Right? So that's a little toggle button. If we go to project settings, input map, we already have the E key set up. And now if we go to the world, or if we go to the top, let's change our bow equipped to equal to false. So now on start, the bow will not be equipped. We click play on the world. We run around, we click the button, we can't shoot, we click E. That picked the apple, but once we click E, we can shoot. We click E, can't shoot, click E, can shoot, click E, can't shoot. And that is how that works, right? So that looks all good. Now, real quick, we need to fix the player's animations that we made back in episode 1. So if we go to our player, we go to our animated sprite, you can see that our attacks have many different frames. The only frame I want to keep is frame 1, this second frame here. So if we go to E attack, if you're following along with the series, we go to E attack. Let's delete every frame in here but the second frame. We'll go to north attack. We'll delete every frame except the second frame. Northeast attack. Delete the first frame, skip over it, and delete the other frames. Northwest attack, all the frames but the second frame. And that is the same along with all of these. So all 8 animations for the attack. We want to delete all the frames except that second frame. And this should not take too long. And that is all of them, right? So that's all of the attacks. So make sure you go do that within the player's animated sprite. And if you're not following along with this survival series, then that should be no big problem there. Just skip over this part. And now we're going to move on to actually creating the player being able to spin around based on where the mouse position of the mouse is. So we'll go back to our player scene, and we'll open up our player scene. And we need to, first of all, we're going to create a area that we can kind of, you know, do for testing. So we'll go up to the top of physics process, and we'll say, well, let's create a new variable first. Let's go up to the top so we can actually test it. We'll say var mouse location. So this is going to be a big variable, mouse location from player. So wherever the mouse location is from the player, it will equal null. And then down here, I want to say, I'm going to copy this variable onto my pad so we can just paste it like this. We'll say this equals the global mouse position. So what is this going to equal? It's going to equal the global mouse position minus the player's position, right? So basically, mouse location from player is going to equal the global mouse position wherever our mouse is minus the player of the enemy, or I mean of the player. So it's going to show us the difference of how far our mouse is from the player. And we can just say print just like this. So if we go to our world and we play our world, we can see that down here in the output, you can kind of see how the mouse works. So when we're right here, you can see the X gets farther this way, and you can see whenever we cross the player, it's going to go into the negatives, and that's how we're going to be able to pick what way we're facing and the way the direction the player is moving. So if we're facing up, well, we're going to need our, first of all, we're going to need our Y to be negative, and we're going to need our X to be positive if we're facing this way. We're going to need our Y to be negative, and we're going to need our X to be negative if we're facing this way, as you can see by the bottom. I'll explain this here more in just a second. But once we have all this here done, we're going to go down to the bottom, and we're going to have to change up all the animations to match the animations that we just created. And I'll explain a bunch of this here in just a minute once we write out the code. So first of all, I want to go here, and we're going to have if bow equipped. We're going to play all this animation because this is what we have already. So right inside of our play animation, we're going to say if not bow equipped. So right, because if the bow is not equipped, then we're going to want to just play all of the existing code because this is all of the normal animations that we already had. So we'll keep it this way. We'll keep all these animations just the same way that they already were the entire time. Just like so. And then we're going to have to, we can come up here and we can close this, make it a little smaller, and then we can come down here and create a new if function, and we can say if bow is equipped. And for now, if bow is equipped, well, nothing's going to happen, and we can just say pass. And if you play the scene, it's going to play the animations. If we equip the bow, it's going to play whatever animation we're stuck on. So if we click, now we're equipped on the bow, you can see it's going to play our idle animation. If we unequip the bow, it's going to start playing our animations again. If we play, equip the bow, if we walk this way, equip the bow, it's going to play this animation forever because that's the last animation we stopped on. So once we start playing our own animations, only whenever this is, it's not going to play the last animation because we're going to be playing a new animation. So how are we going to do this? Well, I'm going to hit a time lapse real quick of me writing out the code, and I'm going to go through and I'm going to explain what all the code does because it's a lot of code, and I want to make sure we all understand what it actually is going on. So I'm going to expand everything, and I'm going to zoom in, and I'm going to hit a time lapse just real quick so we all know what's happening. But I'll be right back. Okay, so now all this code works, and if we click the game, F6, you can see that we have our normal animations. We equip the bow, it goes into the shooting animation. We can spin around in all the directions it points with the mouse, and it will shoot the arrow in that direction of whatever way we are pointing the bow. And it looks pretty good. It looks pretty smooth. Unequip the bow, we go back to normal animations, the bow disappears, the mouse doesn't do anything. We click E, and we go back to holding the bow, and we can shoot in whatever way we want. And you can obviously make this a lot smoother by playing around with it more, but this is the basic code, and it is pretty complex but also pretty easy. It's just a bunch of numbers and trying to understand the way the mouse is pointing. So as you can see down here, if you look at these numbers, you can look at this and you can match it. So this is our north attack. Our north attack is going to check if the mouse location from the player, if the X is greater than -25, or if the X is less than 25. So if it's greater than -25 on the X and it's less than 25 on the X, but it also has to be less than 0 on the Y, because that means it's going to be in the top. So if we play one more time and we look at this, well, you can see whenever we're up here and we're facing north, you can see down there at the bottom in the output, you can see that the X is the first number. We're always under 25. The moment that crosses 25, which is now, boom, it's going to switch and it's going to change directions. When we get within the -25, it doesn't. If we can go all the way over here to 25, and it's going to switch this way. But then how do we know to switch this way whenever we exit 25? Well, we're going to go down here. Northeast attack, that's the northeast animation. We can see the mouse location. Once the moment X is greater than or equal to 25, so once it's greater than 25, up here, it doesn't play this animation anymore because it's no longer greater than 25, so it's going to stop. But if it's greater than 25 and the location from the player is going to be less than -25, which means we're not going to be, you know, super high up in the world. As you can see, once this mouse comes down here, the Y is much lower than it was whenever it's up here, right? The Y up here is much higher than it is once we get down here. So in this range here, you can see the number we have here, which is our Y, and as long as Y is less than -25, which means it's higher than -25, because whenever we get to -25Y, we want to switch to our east animation, and you can see that's what we do. This takes a minute to look into, and you can probably understand it once you see it. But like if you look down at the bottom, you can see the moment we get here, our Y is 25, and that's when we switch. So it's gonna play this animation as long as the X here is higher than 25 and the Y here is lower than -25. Once it's higher than -25, we're gonna switch to east, and that kind of makes it a long loop, and it takes a long time. That's why I didn't want to go through it, but now that you can explain it, you can kind of see how it goes. Just go from the north, see how the mouse is positioned. This is just the mouse position with these numbers down here. So this is kind of how this works, and then it's able to follow the mouse. So F6 one more time. You can see we equip the bow, we're able to spin around. If you don't want the player to be able to move, then you can turn off the movement by calling a little function up here and turning, where is it, the move and slide off here, and then we won't be able to move. Or you can go down here and you can set the player speed to 0. Either or. We can do that just real quick. So whenever this happens, we can say speed equals 0. So the speed is equal to 0. And then where else? If we go to within this here, we can say speed equals 100 or whatever the speed is equal to. So, right? So if we click on the world, you can see that we can move. We click E. We're no longer able to move. We can only spin. I'm clicking WASD right now. We cannot move. We can only spin. And we can move again. Equip the bow. Can't move. And we can shoot arrows. And well, you can see that everything works good. I really hope this video was able to help teach you and understand the best way to implement ranged combat into your own Godot games. Next video or next episode, we will be covering how to create an enemy that drops loot and that will take damage from the arrow our player can now fire. But if you could subscribe to the channel, then it would mean the world to me. And until next time, stay safe and have a wonderful day.